right, hey guys, so I'm gonna talk now about the second function you see here. So this is a square root function, that little symbol, so this is the one we're looking at, f of x equals, whoa, f of x equals the square root of x. This square root symbol is also called a radical. Okay, so again we have, let me draw my graph. You guys already have the graph. Okay, we're gonna state our domain, range, increasing and decreasing intervals. Okay, and then again, as always, I recommend making a table. And we will plot those points. Okay. So just like the last video, I like to choose numbers around 0. And so let's say we did that. Okay, let's say I chose -2, -1, 0, 1, 2. I'm just doing the same things that I did last video, just to show you why I'm gonna realize that I need to switch these numbers up. Okay, remember you can choose anything you want for x initially, but when further looking at the function, we might need to change it up. Okay, so we have a square root. That means I'm plugging in these numbers in my table to that x variable. So let's say we plugged in -2. I'll do that down here. If I plugged in -2 for the x, well, I hope that we recognize a problem here, okay? First off, we know that 2 doesn't have a perfect square root. Square root of 4 is 2, but we don't know the square root of 2. Well, I mean, we could put it in our calculator, but it's not going to be a nice number. So first off, that might not be the best number to choose. We might want to choose numbers that we know have a perfect square root, but also this is a negative underneath the square root. That is a big no-no. We cannot take square roots of negative numbers unless we are working with imaginary numbers, which we are not working with those types of graphs right now. So right now we only want real numbers. Okay, so for these negative numbers, I'm just going to cross them out. We cannot have a negative underneath the square root. Okay, now instead of doing, I know 0 has a square root, square root of 0 is just 0, okay, because 0 times 0 is 0. Square root of 1, well, 1 times 1 is 1, so square root of 1 is 1. Now, I'm not going to do square root of 2 because, again, it's not going to be a nice number. I'm going to change this to a 4 because 4 has a perfect square root. So square root of 4 is 2. Next number I can think of with a perfect square root is 9. Okay, so this should be plenty of points for us to go ahead and plot. Let me go ahead and make my tick marks. Okay, so I have a point at 0, 0. I have a point over 1, up 1. Over 4, up 2. Over 9, up 3. Okay, and now again, since we cannot have any negative x values in our domain, I'm going to start my pin at the origin here and connect the dots as I move left to right. So notice that I'm not actually going past the y-axis because I don't have any of these negative x values. Okay, so there's the parent function for a square root function. And let's go ahead and write the domain. Well, we know we can't have negative numbers, right? We started our domain at this x value of 0. Are we restricted what we can put in the function after that? No, we can put in any positive x value we want. So for our domain, we're going from 0 to infinity. We know infinity has parentheses around it. And then for 0, we are actually including it. We do have a square root of that, so it gets a bracket. Okay, so if we include the number bracket, not included parenthesis. All right, for the range, very, very similar because you're not, notice we don't have any negative values for y either, okay? But this graph, this line is still going to continue moving in the positive, in the up direction. So we're going to keep going towards infinity. So same thing for the range. We start at 0, and those y values will keep getting larger and larger and larger, so towards infinity. All right, what about increasing? Well, if we are following our graph along as we move left to right, notice again that at no point is our pin going down. Okay, we are continuing up and up this entire time. So we are increasing also on this same interval, so 0 to infinity. We are not decreasing at all, so like the last example in A. All right, guys, so go ahead and do the rest of the parent functions on your own. I recommend, again, making tables to help you make those graphs, okay? If you have any questions, just let us know.